Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. A very good morning, good afternoon, good evening to all of you. And this is the TKM2 course under the NPTEL MOOC series, and we are in the 31st class. That means we have finished 6 weeks of class. This is the 7th week's first class, and we will wrap up this course in 40 lectures. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing about the concepts of the fractional factorials, point 1. Point number 2, we did mention, time and again I have been mentioning more in the initial classes, that consider the level of importance. Let me use this word, level of importance of any factor is at 2 levels, consider is good or bad, plus 1, minus 1, 1 and 2, 3 and 4, whatever it is. But here it is given as plus and minus, which means plus mean positive effect of a higher level, minus mean negative effect or being of a lower level. So, consider there are k number of factors. So, the total combinations based on which you will try to model it would be 2 to the power k, degrees of freedom would be calculated accordingly, and the design would be of third design, fourth design, fifth design, depending on the accuracy you want. So, obviously, it would mean that what is the combinations which you are doing. Now, and if you remember correctly, that for any 2 factor model for the fractional factorial, this so called design of experiments, we considered the factor 1 or a along the horizontal axis, which is x, which is my right arm, and I am just repeating this, and the overall reading of the y axis would basically correspond to the second factor, which is b, which is the vertical, which is my left arm, and all the points which you have inside this so called first coordinate, if you consider the Cartesian coordinate, these would give you the information based on which you can find what is the relationship. So, technically it would be a square with 4 grid points being of level of 0 0, where the 0 0 if I am considering the lower level for both of them is 0, and 1 1 being both of them at the highest level. And if it is minus 1 plus 1, the grid points would be minus 1 for the lowest level, other 3 points would be correspondingly to minus 1 plus 1 plus 1 plus 1 and plus 1 minus 1. Now, if we expand it as we did discuss in the last class to the factors being 2, but if they are the level of importance is basically 3. Level of importance means basically high level, moderate level, low level, such that we give them a so called points in the quantitative values as plus 1, 0, minus 1. We can also give as 1, 2, 3, but I did mention that why 1, 2, 3 would not be the right approach in order to basically analyze the problem, and I did give 2 very simple examples from the area of civil engineering and electrical engineering, and it can be expanded in any sphere. So, it can be in accounting, it can be in marketing, it can be in psychology, it can be in finance, whatever areas they are. Now, when you consider the 2 factors with 3 level of importance, you will basically have again a square of grid. Now, points would basically be levels, each would be basically at level of minus 1, 0, 1. So, A would be at minus 1, 0, 1, B would be at minus 1, 0, 1. So, you will basically find out the combinations accordingly. Now, if you go to the higher level, higher dimension, 3 factors. So, consider A along the x axis, which is my right arm, B along the y axis, which is my left arm, and the other value C consider would be either towards you or would be coming away from you. So, you will basically have a so called cube or a cubic cube sort of thing. cube in the sense if there are only 2 levels, Rubik cube would be the sense for if we have more than 2 levels of fx for each, like +1, -1, 0 and so on and so forth. So, with this we will continue the discussion, and we did discuss also the fold effect models, where we consider the folding or accumulation of the collation of the effects for the factors such that they give us better predictions. Your main your answer is to basically able to utilize the least set of information to get the maximum set of output. So, the letters obtained in the square. So, we are considering the square of the grids, where the values of q is equal to 0, r is equal to 6 and s is 18, and the sum of the squares between the totals would obviously be, you find out the sums as 0 square plus 6 square plus 18 square, and divided by the corresponding factors, you will get a 28 with 2 degrees of freedom which you have. The sum of the components would become, so now again if you remember that whatever the overall variances or overall I will not use the word discrepancy, but whatever the difference in the actual reading and the predicted reading was. So, they would be two things: the total sum of the squares of the errors, or the sum of the squares of the readings, the difference in the reading would be given by some component which you can predict and some component which you cannot predict. So, it is basically sum of the squares would be divided into two components. So, this is what we will again consider. So, that is the basic notion which we are trying to find out. If you remember, I just mentioned that you are trying to utilize the least number of variables or least number of so called resources to get the maximum prediction value or the maximum output in whichever words which you use. The sum of the two components comes out to be 61.34, which is the sum of the squares or A B, with degrees of freedom being 2 and 2, depending on, because you have the grids based on the fact that the number of variables are accordingly. So, you will basically have the degrees of freedom as 4. In general, the sum of the squares computed from the square is called the A B component of the interaction, and the sum of the squares component from the square B is called the basically the A B square. It is basically a notion of how you mention it, is A B square component of interaction. The components of A B and A B square each have 2 degrees of freedom, and we can basically find it accordingly. The A B and A B square component of interaction may be computed another way. Consider the treatment combination totals in each square is in figure 9.3. If we add the data by diagnosis by the diagonals downwards from left to right, we obtain the totals given as 6. So, you are trying to basically find out the total, and 18. The sum of the squares between the totals is given as 28.00. Similarly, the diagonals towards the down right from left to right are given as -2 and 18, and you can find it accordingly. The sum of the squares between the totals which is A B is 33.34, and yet called these components of the interaction as the ing components of interaction, based on which you can use both notation interchangeably and find out the values as I as A B square and j as A B only. Now, consider the 3 to the power 3 design, which is basically your 3 factors and they are 3 levels of designs. Suppose there are 3 factors A, B, C under study, and that each factor is at 3 levels arranged in a factorial experiment. This is a 3 to the power 3 factorial design. If you see the curve, it basically gives you that information. So, basically you have 0 0 0, which means they are at the level of lowest level for each A, B, C. So, A factor is along, I am basically marking it. Let me use a different color. So, A is along X, B is along so called Y, and Z is as for the C. So, now I use a different color, the yellow and the highlight. Okay, let me use the yellow and highlight. So, this is for 0 0 0, which means they all of A, B, C are at the lowest level. This is 2 2 2, which means that all A, B, C are there the highest level. So, 0 0 is for the lowest, 2 2 2 is for the highest, and obviously there are intermediate values. So, what is the intermediate values, where all of them are the intermediate values would be 1 1 1, and correspondingly the combinations are, you can have 0 0, where I am just hovering. I will use another color to make it a little bit clear. Let me use a green color. So, this would be the combination A B at low level and C at a moderate level. This would mean A B at the low level, C at the highest level. Similarly, if you have 2 to 1 would basically mean A B at the highest level, C at the moderate level. Again, if you have, so I am going in the downward direction, now A B at the highest level, C at the lowest level. So, this need not be 0 1 2, it can be -1 0 1 depending on whichever convention you want to use. So, based on this you have the treatment combination of 3 design. The 25 treatment combinations has 26 degrees of freedom, because if you count the numbers in this so called Rubik cube. So, basically in the lower plane you would basically have the combinations would basically start from 0 0 0 and it will go to the extreme end as 2 2 2. So, at the lowest level you will have combinations as 0 0 0, 0 0 1, 0 0 2, then you have 0 1 0, 0 2 0, then you will basically have 1 0 0, 2 0 0 and basically proceed accordingly. So, these are 27 treatment combinations and each has 26 degrees of freedom. Each main effect has 2 degrees of freedom, each 2 factor interaction has 4 degrees of freedom and this 3 factor interaction has 8 degrees of freedom corresponding to the fact that we have already studied. So, 2 degrees of freedom for each, 2 factor interaction would have 4 degrees because 2 into 2 and 3 factors would have 8 degrees depending on one is being subtracted because you are losing 1 degrees of freedom. If there are m replicates, that means you have basically trying to replicate it for n number of times, the total number of degrees of freedom would be n 3 to the power 3, that means 3 factors to the 3 levels of interaction multiplied by n number of replicates minus 1, because you will always lose 1 degrees of freedom. The total degree of freedom for the other case would be the replications would be given as 3 3 and bracket n minus 1 depending on the combinations you are going to take. The 3 factor interaction ABC may be partitioned into 4 orthogonal 2 degrees of free components, which are usually called W, X, Y and Z components of interaction. They are referred to as corresponding to how you basically denote as AB square C square, AB square C, then ABC, and correspondingly you can also consider ABC square, A square BC and so on and so forth depending on the combinations you are going to take. The two notions are used interchangeably. So, if you use W x y z or U v W x y z, the combinations would be denoted as technically as consider for W you are denoting as A B square C square. In another case, if it is x, it could be A B square C, in another case is y, it will be A B C square. Say for example, in another case it is V may be denoted by A square B C. So, depending on different type of conventions, you will not what the conventions, depending on the nomenclature you will use these combinations accordingly. A machine is used to fill 5-gallon metal containers with soft drink syrup. So, you are trying to basically fill up a metal containers. The variable of interest is the amount of syrup lost due to frothing. So, obviously, when you putting some fizzy drink like Limca or Coke or Coca-Cola or Thumbs Up or Pepsi, whatever it is, or some aerated drinks, they would be frothing and you want to minimize the frothing and minimize the loss. There are 3 factors are thought to be influenced are the nozzle, the design. So, what is the diameter, what is the so called aperture radius, what is the filling speed, high the filling speed, high is the frothing, low the filling speed, low the frothing, but obviously that will reduce your productivity. In the same case, if the nozzle diameter is high, then obviously you can fill faster, but if the nozzle speed aperture is or the radius is low, then you have to basically fill slower. So, the speed would also change. And the 3 being the operating pressure, higher the pressure, more the frothing, lower the pressure, less the frothing. So, but obviously higher the pressure would mean that you are able to have a total quantum of carbureted air or the carbon dioxide at a much higher level, not for lower pressure, but obviously it will have a other effect, that means higher the pressure, more the frothing, more the loss, lower the pressure, less the frothing, less the loss. So, I am just giving you a qualitative feel. 3 nozzles, 3 filling speed and 3 pressures are chosen. So, now you see that till now we had considered 2 levels of pressure plus 1 plus minus 1 0 plus 1 minus 1 so on and so forth. and now we are choosing 3 levels of pressure. So, they can be denoted as +1, 0, 1, 1, 2, 3, whatever the combination. Similarly, we can choose the filling speed also at 3 levels, and you can consider the 2 replicates which are there. So, if you consider the 3 factorial models, the pressures in square inch pounds per square inch. So, which is the leftmost column. So, these values are 10, 15, 5, and the combinations which you see, you have basically the nozzle type being A, and then you are considering the speed. So, pressure and speed are the variables, and you are considering the nozzle type A. So, you have basically nozzle type being of 100, 120, 140. So, consider them as the pressures which are given. Speed you can basically find out depending on whatever the combinations which you have. So, if you look at this table, so it gives you the syrup loss data for example 9.1, and the units are cubic centimeters, and they are there. So, the values which are given for different combinations are in this table. So, if you consider for nozzle type 1 and the leftmost column 100. So, obviously, you will have the loss given as -35, -25, 110, 75, 4 and 5, corresponding to the other values. You will have the whole gamut of the data in front of you. The analysis of the variance for the syrup loss data is shown in table 9.2. The sum of the squares have been computed by usual methods. We see that the filling speed and operating pressures are statistically significant. All these two factors interaction are also significant. The two factor interactions are analyzed graphically in figure 9.4. So, which is the right hand figure which we have, we will consider that in a little bit more detail. The middle level of speed gives the best performances as we see, because in that case the frothing the loss or the loss due to the frothing, because they are spilling over, is the minimum, is the least. The middle levels of speed gives the best performance of nozzle 2 and 3, and either low that is 10 psi or high 20 psi pressure seems more effective in reducing the syrup loss. So, if you consider the source of the variations, so source of variations are given in the leftmost columns, which is A, which is the nozzle, B the speed, C the pressure, and the different combinations are there, which you have AB, which is speed and speed and the nozzle dimension. Then AC would be the nozzle dimension and the pressure. Speed and pressure means at what pressure you are filling that aerated ring, and the pressure is at what pressure it is coming. So, it is just a repetition I am saying. If you have combination of BC, it means basically nozzle is kept fixed, dimension is kept fixed, and the speed and pressure are being varied. If ABC basically are combinations are there, obviously you will consider all three of them and at different combinations, and obviously there would be an error. The sum of the squares of the error of sum of the squares are given. The error value comes out to be 11,515, which is this value, and the total sum of squares comes out to be 1,74,102, and the degrees of freedom are given accordingly, because if it is only one factor, it is 2 factors is it will be 2 into 2, it is 4, and when you have basically all the 3 combined factors, it will be 3 into 3 into the 3 factors considered, and you will basically have 8, because it will be 2 into 2 into 2, not the 3 parts, sorry. The mean squares would obviously calculate, you know that you basically find out the mean squares, which I am highlighting by dividing here this 993 divided by 2. So, obviously it will come out to 496.89. I am not repeating the decimals. If I consider, say for example, the value of 69,105 divided by 2 would give you the mean square as this. Similarly, once you find out, you can find out the f value depending on the left hand side or the right hand side on the degrees of freedom which you have. So, the p values and the f values are found out, and you can basically comment whether they are significant and non significant. So, f values, I will just repeat it, which is the second last column, starts from 1.17 for nozzle A, only the nozzle effect, 71.74 for B, which is the speed, 81.01 for C, which is the pressure, and corresponding to AB, AC and BC, which is corresponding to nozzle and speed combination, then corresponding to nozzle and pressure combination, and finally speed to pressure combinations. The F values are 3.69, 4.04, 40 and 7.53. So, based on that you can find out the p values. So, if you look at the graph, So, these combinations are the least, I am just highlighting, and in this combination it is a high level. I am just highlighting few of them. So, if you read it, I will again read the what is given. The analysis of variance of ANOVA for syrup loss data is shown in table, which is 9.2, which I have just discussed, and the sum of the squares have been computed by the usual methods and we fit it. We see that the filling the speed and operating pressures are statistically significant at all two factor interactions are also significant. So, there are the two factors and interactions being two factors for this effects. The two factor interactions are analyzed graphically in the figure which I have just marked here in this arrow, and if you see the middle level of the speed gives the best interaction. So, middle level of the speed where I am hovering, the red highlighted part or red circle part are at the minimum level, because they give the best so called prediction. So, now if I do it for the nozzle type with the combinations of nozzle type was basically A, if you remember. So, if I predict the A to C cell totals, that combinations of nozzle speed and pressure being there, then you have again the combinations given for, again we find out the second level are the best. So, here again we find out the second level are the best, but these are combinations of speed and and the combination of B into C, the combinations or totals. So, these would give you the best way how you are trying to find out what is the best effect. The 3 level design often finds some applications, one or more of the factors are can be qualitative, and again obviously you may ask the question what happens if all of them are quantitative, but they are at different levels, like one is at 3 levels of importance like -1, 0, 1, +1, another can be say for example at 5 levels of importance, maybe depending on the thing. So, it can be -2, -1, 0, 1, 2. So, how you do that, obviously the concept would be the same, but we will try to basically explicitly go into the details of the simple case, and those complicated case can be analyzed accordingly. The 3 level, so let me read it. The 3 level design often finds some application, one or more of the factors are qualitative, naturally taking on 3 levels, and the remaining factors are quantitative. In this example, suppose only 3 nozzle designs are of interest, this is clearly then a qualitative factor that requires 3 levels of importance. The filling speed and the operating pressures are quantitative factors, therefore, we can fit a quadratic model in the 2 factor speed and pressure at each level of nozzle factors. So, obviously, here pressure, nozzle dimension and speed are quantitative. So, we are able to handle it in one way. If they are qualitative, we will do it accordingly, but obviously, if you remember, there were some discussions where qualitative factors were converted into quantitative factors and the work was done accordingly. So, now we are going to fit a regression model. So, the regression models would basically be with respect to, like say for example, you want to find out the nozzle type and where x1 is the speed, x2 is the pressure. So, we are basically regressing one of the factors on the other depending on what we think, because speed and pressure would basically be more on our control. So, based on that we want to find out what is the nozzle dimension, because nozzle dimension once fixed cannot be changed abruptly. So, speed and pressure are the factors which you can change depending on how the experiment and how the loss of the frothing is going on, because dimension of the nozzle cannot be changed instantaneously. Once the machine has been designed, has been purchased, it is fixed. So, try to understand that. So, the nozzle type are given, if you remember, of 3 types, 3 dimensions, 3 nozzle diameters, and the speeds as I am just repeating it, x1 would be the speed, x2 with the pressures and in their coded units. So, in all these 3 cases you will basically have different regression models, but the point is that rather than having a simple multivariate where the multiple linear regression, we consider a combination of that. So, what would be the multiple linear regression would be? You will basically have the effects coming from x1 to 1 degree, x2 to another 1 degree, and the rest would basically be the error part. Obviously, you can consider a beta naught term depending on the the level at which it cuts the y axis. So, if you remember, I did mention y is equal to m x plus c the equation. So, this value is c I am basically denoting as beta naught. Now, if you want to basically extend that influence, so you will basically consider the combinations to the second degree. So, the second degrees would basically be where you were considering x 1 squared, x 2 squared, and also the combinations of x 1 and x 2 can be considered as a multiplicative factor. So, obviously, the model would basically be beta naught. I am just repeating it, what is the answer is exactly the same once you analyze the problem. So, y would be equal to y, I am again repeating, is the nozzle, and why the nozzle, I did mention that once it is designed it cannot be changed. So, your speed and pressure are the independent variables. So, y, which is the nozzle dimension, is equal to beta naught, plus if it is a regression model where the degree is 1, it will be beta 1 into x 1 plus beta 2 into x 2 plus epsilon. So, obviously, all the assumptions will hold, that normality, then the mean value of the error, variance of the error, and so on and so forth, and the covariance between the independent variable and the error terms being independent and being 0, and errors being independent from time to time. So, these factors, so if you extend it to the quadratic model, it will be y is equal to beta naught plus beta 1 into x 1 plus beta 2 into x 2 plus beta 2 into x 2 square plus beta 1 1 into x 1 square plus beta 1 2 into x 1 and x 2 plus epsilon. So, based on that we solve the model. So, this is what it would be. This is the predicted value. So, obviously, the error terms would not come. So, this would basically mean the beta naught. I am only highlighting one of them. This 3.5 would basically be beta 1 with a factor of x 1. This 16.3 would basically be beta 2 with a multiplied by x 2. This would basically be beta 1 1 multiplied by x 1 square. This would basically, so now there is a negative term. So, this would be basically beta 2 2 with a minus sign with x 2 whole square, and this one basically would be beta 1 2 multiplied by x 1 2. So, I will just write them. So, technically your equation would be in the simple case y is equal to beta naught. This is the multiple linear equation, remember that. So, obviously, when you fit and find out the regression, so it would be y hat is equal to beta naught hat per beta 1 hat So, obviously, the error term will not come. Now, when I consider the higher model, it will be y is equal to beta naught plus beta 1 x 1 plus beta 2 x 2 plus beta 1 1 x 1 square plus beta 2 2 x 2 square plus beta 1 2 x 1 x 2 plus epsilon. When you fit it, so I am just basically coming here, y naught is beta naught hat, which is here, plus beta 1 hat x 1 plus beta 2 hat into x 2 plus beta 1 1 hat. This hat means they are the predicted values, x 1 1 plus beta 2 2 hat into x 2 . So, these values which I have is this. I am just giving you the hypothetical values depending on this. This will be 16.33. Similarly, the last one 1 2 would basically be 2.9. So, we will consider this model in more details later on. So, with this I will end the 31st lecture. Thank you very much for your attention. Have a nice day.